Day once again. So now let's look at the second topic of this module. So the second topic is about frameworks. So frameworks are mostly used in the design of roof trusses, bridges, structural work. So 3.3.1 says represent by means of a diagram a roof truss supported at 2 points and carrying not more than 3 vertical loads. Determine graphically or analytically the nature and magnitude of the forces in the different frame parts restricted to triangular roof trusses consisting of not more than 9 frame parts. Okay, so what we're going to do here, we're going to be calculating the nature. It says here, the nature as well as the magnitude of the forces in the different parts of the framework. So we're going to be looking at how much forces are in the members. So these parts are called the members. All these are called the members. Where the bridge is resting, that is the resultant, the support. Sorry, the reaction force. This part where the bridge is resting on, it's exerting an upward force on the bridge, supporting the bridge. But the forces that you find in all these parts of the structures, these are called the members. So we will be calculating what is the nature of the member. When we say nature, we mean is it a pulling force or a pushing force, and then the magnitude as well as the magnitude. So this is more clear. These are the reaction forces. This is the reaction where the bridge is seated on, and these are the members. All these parts are called the members. Okay, so this is just a different structure. So this bridge is seated on rollers, as you can see there. Still has the reaction force. The reaction force, these are downward forces acting on the bridge, and these are the members. Those are the members. Okay. So in a simple framework that we're gonna look at in N3, we're only gonna focus on the joints where you have a maximum of 3 forces or members. So these, the 10 kilonewton and that 15 kilonewton are called the reaction forces. Some examiners will ask you to calculate one of the forces. So sometimes they give you both of those ones in 1 year. So in such a case, you can just say upward forces are equal to downward forces to get the unknown reaction force. Or sometimes they give you distances. If they give you distances, it will enable you to take moments to calculate that reaction force. So it depends. And I've already said that those are members. Okay. So when we say a joint, we're talking about a point. For instance, that will be a joint. This is a joint. This is a joint. So I say for the N3 syllabus, we are limited to a point to a joint with 3 forces. Like for instance, this joint has got 1, 2, 3. So we could work with it. This joint has got 1, 2, 3, 4. So we cannot work with it at N3. Okay. So they want you to calculate the members. So in this one, you see, because the labels are here, the question was asking to calculate this member as well as that member. So in N1, we did a topic triangle of forces where we used the method of Bow's notation to sketch a space diagram as well as a vector diagram. I'm not sure how many of you grasped that, but this lesson depends on that knowledge. So we make an assumption here to do our calculations. We assume that each joint is in equilibrium, because if it's in equilibrium, then we can do a vector diagram. How to determine the magnitude and the nature of the members? So you first figure out which joint are they looking for. Which joint must you focus on? So here the question was calculate RP and PQ. So we were focusing on that joint. So that is RP and this is PQ. So these labels, they are actually labeling this whole space inside here is space P. And this whole space outside here is space Q. That whole space outside there is space R. So you name the member using the two spaces on both sides, going clockwise. So this member falls between P and R. We're going to call it RP, going clockwise. And this member falls between P and Q. We're going to call it PQ. Okay. So step 1, you need to sketch the space diagram of the joint in concern. So the joint that they have given you. And how do you sketch a space diagram? Okay, now I overlooked to make an original sketch of this one. So let me make a quick sketch. I'm going to have to make a rough sketch now because I don't want these videos to be too long. I'm just going to make a quick rough sketch just for me to show you what is a space diagram. I think I do have a vector diagram. So that one is 15 kilonewton. Yeah, you have 10 kilonewton. Let me just see, maybe I do have, oh, here is a space diagram. Yeah, so a space diagram is basically a sketch whereby you just take the forces that are in that joint that you are busy with. You leave everything else out. So this diagram is not according to scale. It's called the space diagram. So here you are showing the 10 kilonewton force, you're showing the member RP and the member PQ, and you're showing the angle because that is all that is important, that concerns that joint. And then secondly, you sketch the vector diagram. So from the space diagram, you sketch a vector diagram. Then how do you sketch a vector diagram? You use Bow's notation. So the 10 kilonewton is the one force that you know in direction as well as in magnitude. So you start with that force. It's an upward force, you go up. So from this force, you go clockwise to pick up the next force. You pick that force up, but you need to sketch it as it was. Don't change the shape. If it's sloping this way, it must keep sloping that way. And then the remaining force, you just use it to close your triangle. Okay. So the first force was starting from space Q going to space R. We go clockwise from space Q going to space R. So it's QR. Then the next one started from R going to P. So you label R there going to P over there. And then the last one is between P and Q. It comes out automatically. So the key thing here, you can go to other YouTube channels and just check how to do a vector diagram to get a thorough explanation of that. Like I say, it's an N1 topic, so I won't dwell much on that. So the first step is you do your space diagram. The second step, you do your vector diagram. If you've got your vector diagram correctly, the given force is now here. That 10 kilonewtons that was given, it now falls here. Okay. Let's see if I didn't edit. Oh, there it goes. So that is the 10 kilonewton. Then you just make these other ones, you give them directions, you just make them follow the 10 kilonewton force so that you have a closed diagram as per the definition of the triangle of forces. Then to calculate PQ, you've got now the opposite side. This side is opposite to the angle. So you calculate PQ. PQ is adjacent to the angle. So you're gonna say tan theta is the opposite over adjacent. Tan theta is opposite over adjacent. That's gonna give you PQ. And then sine theta. To get the PR is now the hypotenuse. You're gonna say sine theta. Sine theta is opposite over the hypotenuse. Okay. And then to know whether it's a strut or tie, you will take these directions and put them back here. You'll take these directions and put them back here. So the PR is this one. It gives you a downward direction. So the downward direction, you will sketch it here closest to the joint. And then on the opposite side, you're just going to sketch another arrow facing the opposite way. So at the end, you're going to end up with something like this. They got the sketch here. Just going to show you how it's going to look like, how a tie would look like. Okay, that's fine. It's wasting my time. I'm just going to sketch it. So a tie will look like this. So this is how you are going to transfer it back to your framework. So you got a downward direction from your sketch. So that downward direction, you sketch it here. Was it downward? Yeah, your vector diagram standing like this. Upward, downward, and that way. So you make it go face downward, and then on the other side, you just make an opposite direction. So that white book, actually, Mullman has got this. A tie will look like this, and a strut will look like that. Will look like that. So your nature will either be a tie or a strut. So this one, it looks like a strut. They are facing the opposite directions. So your horizontal force, you see that your horizontal component is facing that way. So you make it close to the joint, and then on the opposite side, you just make an opposite one. So this one, let me just see, where was R? RPQ. I think it was like that. Yeah. RPQ. So PQ is a tie because it looks like a tie. It looks like that. And then RP is a strut. If they are pulling away like that, if the member is under tension, it's a strut. If the member is under compression, it's a tie. Okay. So tie is for compression. And the strut is when a member is under tension. So a member always have a two-way force. Unlike that one is just upward. It's got a two-way force like that. So that is how you calculate your strut and your tie, your members. Okay. Now, if you've done this correctly, every time the member that is on a slope is going to be a strut, you're going to use a sine theta to calculate it. And if you've done your triangle correctly, and the horizontal member will always be a tie, and you will use 10 to calculate it. Okay. So that is the frameworks. Let's do an example. So the example, we will take it from the previous question papers. Okay. So here is a question. The question says here, below, figure 5 below shows the structure. Determine graphically or calculate the magnitude and nature of the forces in members PQ and what? And PR. Okay. Okay, I was reluctant to show this because this is not a proper method, but I think I can show it for those that did not understand about notation in N1? What if I never understood the triangle of forces or Bow's notation in N1? Then you're gonna have to memorize the summary version of this lesson. And here it goes. You will always have that member that's on a slope and this member that's on a horizontal. Depends which one they are looking for. In most cases, they're looking for both, but they can look for just one. So your summary goes like this. Your horizontal member will always be a tie. When you've done your triangle correctly, it's gonna come up as a tie. Then to calculate the magnitude, you will say the reaction force over tan theta. And then your sloping member, this member that is on a slope, will always be a strut. And then to calculate it, you will say the reaction force over sine theta. Okay, so it's quite easy to remember. The sloping member is a strut. You use the sine to calculate it. But the reaction force is always the numerator and the trig ratio is the denominator. The horizontal member is a tie. You use reaction force over 10 to calculate it. So that is how it's going to be. So 2P, for instance, is a horizontal member. It's a tie. And then 2P is 10 over 10. And then RP is on a slope. So RP is a strut. The one that is on a slope is a strut. So it's 10 over sine theta. Okay. And that's all. So I'm going to use the summary version to do the lesson because it just goes quicker. So, but it's the best is to sketch that vector diagram. So the question says, determine graphically or calculate the magnitude and nature of the forces in members PQ and PR. So what you're gonna do here, you first gonna do, yes, this one, okay. You first gonna do your space diagram. So your space diagram, you simply just take the forces that are in this joint. There's a 60, there's force B, there's force R, space P, space Q. So you don't concern yourself about this joint or that joint. It's just this joint because these members that they are looking for are part of that joint. Then you do your vector diagram. Your 10 kilonewton up, and then from that you go clockwise to take this force, that member, and then it stands like that, and then you just use this one to close it off. Then you give it directions, make it follow the known force. Okay. And then so this is 10 kilonewtons, and that slope one is so the 10 started from Q and it ends at R. So it starts at Q and it ends at R. And the slope one starts at R and it ends at P. And the horizontal one starts at P, it ends at Q. So it stands like that. So here's your RP. I can just write it here. RP. And here is your PQ. And you've got 10. So you've got this angle because this is the angle that it makes between the horizontal member and the sloping member, the horizontal member and the sloping member. So you will say tan 60 equals 2 opposite over adjacent. Therefore, PQ is going to be 10 over 10, 60. You calculate the magnitude and you say because so you take these directions, you transfer them back closer to the framework, and once it looks like that, it's a tie. And then for your sloping member, you're going to say, for your RP, you're going to say, because it's a hypotenuse, so it's going to use sine 60 is opposite, which is 10 over RP. Therefore, RP is gonna be 10 over sine 60, which is you calculate and you take the direction back to the framework, put it closer to the joint and the other one just the opposite side. And then if it looks like that, it's a strut. Okay, it's a strut. So if you use the summary version, of this lesson. You're just going to say, my horizontal member is a tie. So what is my horizontal member? It's PQ. You're going to say PQ is a tie, and it is equals to the resultant, the reaction force over tan 60. It's going to give you the answer. And then you're going to say my sloping member, which is RP, is a strut. Now you know that the sloping one is a strut, and it is equal to the reaction force over sine of the angle. So the S and S there must remind you, the T and the T there must remind you. Okay. So that's basically how it works. So we can just calculate the answers just to see. Where are you, calculator? So 10 divided by tan 60 is giving us 5.77. So this is kilonewtons. Kilonewtons there. Just didn't have enough space. And then 10 divided by sine 60 is giving us 11.547 kilonewtons. Your SI units must be correct. So that's all. Let's just do another one quickly. So yeah, they want A, B, and BC. Okay. So just by looking at it, AB is on a slope. So I said the sloping member is gonna be a strut. Then it's the reaction force over sine of the angle. And then the horizontal member, BC, will be a tie. It's the horizon is the what? The reaction force divided by the tan. So you can easily find it this method. So you calculate. There you got your 6 marks. It's normally 1, half, half, 1 the answer. 1, half, half, 1 the answer. It's normally like that. So it's normally 6 marks. Hence, I felt I could give you that summary version of the lesson so that you don't miss out on these 6 marks because you didn't understand your N1. But the proper method is to first get your space diagram, then your vector diagram, because there's always going to be the reaction force that's already given, or you have to calculate. Once you got that, then you'll have to calculate now using your vector diagram, calculate the other 2 sides and tell the nature. Okay. And that's all.